Welcome to the Tyre Recycling Podcast and welcome to episode 11. Thank you for joining us. I'm Richard Wilson and as ever, Ewan Scott, the editor for Tyre Recycling, is here with me. Ewan, could you give our viewers a hint into what we have in store for episode 11?
Today, we're talking with George Kassab from Modern Advanced Polymers in Lebanon. George approached us about some news about his company, which dates back to 1938. So we're going to talk to George and find out a bit more about Modern Advanced Polymers and their interest in the tyre recycling sector.
Great. It's always intriguing to delve into markets that rarely get as much coverage as, the more well-known European and North American markets. What are you looking to find out from George and Modern Advanced Polymers?
We really need to find out what their interest is in recycling. This is a company, as I say, it has been around since 1938. They're in their third generation, family business. And looking at their website, they're involved in a wide range of applications of rubbers and polymers. So they bring a different mix to the recycling sector. Instead of people who are recycling rubber and then looking for markets, they have the markets and they're also recycling rubber. It makes a change.
Definitely. Well, this appears to have great potential for a great interview. And I'm really looking forward to finding out what George has to say. So without any more waiting around, we have that interview available for you right now.
We're speaking with George Kassab from Modern Advanced Polymers in Lebanon today. George is representing a company that's been in business since 1938.
Correct, yes. I'm a third generation in this company.
Okay, Modern Advanced Polymers, as its name suggests, works with rubbers and plastics across a wide area of industries. So, George, tell us a bit about the background of Modern Advanced Polymers.
Yes, definitely. First of all, I'd like to thank you for having me on board, and I respect a lot your work, and I'm very grateful for the opportunity. To talk just quickly about Modern Advanced Polymers, it has been around since 1938. My late grandfather started this business when he discovered that there is a way to reclaim the cut-offs that they used to throw away from the shoe industry when they used to make the soles. So and back then they used to cut off the design of the sole and throw away the residues. So he found out a way to reclaim and repurpose them so they can become sheets again, and they would use them instead of importing them. So this is how it all kicked off. And we went later on to catering several departments on the go. He moved later on to catering the tire business for everything related to patches and stuff like that. And then he moves to the spare parts for cars until we recently upgraded and updated our departments. And we now cater the construction department, the geotechnical department. We cater the heavy duty industries as spare parts, and as well the recycling sector. We ventured into the recycling sector by recycling the industrial waste and by recycling tires.
Okay, so you have the full range of polymer use. So you have the initial manufacture of rubbers and polymers, and you're capturing your industrial waste. Initially, you were capturing your industrial waste, and now you're recycling that, and you've added tire recycling to your range, and you have markets for all your products through a wide range of industries. I see.
Yes.
Do you use your rubber materials in your geotechnical, your road construction, your anti-vibration departments?
Well, it depends. In geotechnical and in road construction, it is rarely used. Sometimes it is used in ratios of 5% just to improve the quality of the product. Because as you know, in the recent studies, they noticed that when you introduce the recycled rubber in small quantities, it reduced the bubbles that that emerge during the vulcanization process. And even in tires, it is as well used right now. But we mainly use it for anti-vibration pads for air conditions, for lightweight machinery, for generator mounts. In these departments, it is used in ratios up to 30, 40%, and sometimes 50% without compromising on the quality.
Okay. This is interesting because much of the focus of tire recycling, rubber recycling, has been getting either tire-derived fuel or rubber granulate for infill. People in the rubber industry tend to think that introducing recycled rubber into their rubber compounds creates challenges, issues, lowering of performance, etc. But you're saying that that isn't necessarily the case.
Not necessarily. You know, we have benefited from our long time and accumulated experience in the manufacturing of rubber to be able like to introduce the recycling part and to diversify the portfolio of the items you use for recycling, because like you just have said, people tend to go for infills, they tend to go for rubber tiles, for gym flooring, for playgrounds, because it is a very easy way to like to sell out the product. You only use the PU binder and then off we go. But if you think on the long run, you are creating a temporary solution, because this style is not eco-friendly. It is not recyclable because you use the PU binder inside it. So, for example, in related to floor parts, we are currently pushing to make a tile without a binder. So if we get to make this breakthrough, we will be solving the problem on the long run. And this is one item to speak about.
That is a project we would definitely like to hear more about in the future. Now, you contacted us about some overseas projects that you might be interested in. Are you looking to export your products, your technology, or are you looking to invest in other projects abroad?
Well, we kind of are open to the two options, because as we were discussing, in this type of business, you have the recycling, which everybody calls recycling, but eventually it is shredding, where you collect the tires and you shred, and then you separate the steel from the textile. And now where everybody stops, we start, because it is our problem now to turn these granules or this powder in whatever form it is into useful products. So it's either we can like export our technology even in the tire shredding part, because we managed, because of the economic situation of Lebanon and because of the main difficulties that we are facing in the inflation rate and everything that has happened, we managed to create a tire shredding facility. It is still on a pilot basis, but we have proven that it is working, that has the lowest carbon footprint in the market compared to the existing shredding facilities that are available in Lebanon, Syria, and Jordan, for example, just to compare in the surrounding countries. So we are open to both options.
Oh, can I ask you about your shredding equipment?
Yes.
Is this something that you have developed in-house?
Yes. But like I told you, because we know how the tire is made, because we are already manufacturers, we know how it is constructed, and we know each and every bit of the shortcuts that are used, where the steel is exactly, and how it is bonded to rubber. So because we know that, it has been a lot easier for us to reverse engineer the process and to extract as much steel as possible from the tire before shredding it. Because usually shredding facilities have huge machinery, because effectively they are shredding steel, the steel wire. They might debead the tire and remove the steel rim, but you still have the layer that is inside the case, which is usually in radial tires is quite a big chunk.
Okay, so you're not following the conventional
Exactly.
shredding process.
Exactly.
You're taking it. I'm now really interested. You're now taking the tire apart without actually shredding it.
Exactly. We're trying to this is the exact word, to take it as much as possible apart before entering the shredding phase. And by this you reduce the maintenance of your blades, the wear and tear. You don't need big shredders. By that you don't need big generators. By that you have a lower carbon footprint. So this is the main core idea that we are really focusing on right now. And this all happens because you are in need. So we are facing a very big, tough situation in Lebanon. So it is pushing us to pass the boundaries in that sector.
Right. This is interesting. I have visions of tires being buffed down to the wire and the rubber being separated. That it leaves you with just a steel mesh and what's left bonded to it to deal with.
Definitely.
So you have a high percentage of high quality rubber.
Definitely steel free.
You would have a secondary production of rubber that may have a wire content.
Yes, exactly. Which can be removed by the magnetic system later on after finalizing the shredding part.
Yeah. It does always amaze me when I go to a tire shredding facility and I see the size of the equipment that they have to use to shred tires. If you have found a less complex way, a simpler way of dismantling the tire without using the energy, without using the heavy equipment in the same way, then that must surely give you a huge advantage in the market.
Well, to be just clear and honest about it all depends on the end product you need and on the business you would like to cater. Like if you want to cater cement plants and you only need 10 centimeter shreds, you will definitely go for a huge shredder, and our business will not be viable. Our concept will not be viable for this business. But if you are aiming to collect a really good product as granulate or powder at the end and really turn it to useful products, we look forward to attain a very feasible and a very modular plant that can be that you can expand. Like you can start with a production capacity of 3 to 5 tons per working shift, and then you can achieve 5 tons per working hour. So this can be all scaled, and this can be all inserted as slots or modules if you work in the method, if you use the method that we are aiming to use.
It's accepted that tire-derived fuel is part of the recycling process. I suspect that governments accept tire-derived fuel as a solution because it's a volume solution. Definitely. And it makes a problem go away, but it isn't circular.
It is not. It is not.
But what you're suggesting, what you're promoting, is a far more environmentally friendly, a more circular process that would have better longer-term benefits for the rubber industry.
Exactly, because the demand on rubber is rising so fast that even the natural rubber plantation or the synthetic rubber production cannot cope with it eventually, because not only humans use rubber, but maybe every being living being might be able, because it is used in livestock, it is used in poultry farming, it is used everywhere. in a single car, you have more than 200 items that are made out of rubber. So the demand on rubber is picking up very fast, and you have to eventually find an alternative source for raw material. For example, why should I go and make mud guards out of synthetic material or natural rubber or even a blend when I can go up to 90% in recycled rubber and keep the quality intact? This is what we are talking about.
Exactly. Does your process include some form of devulcanization?
Yes, when you attain the shredded part or the powder part at the end of the process, then starts the process of turning this type of powder into reclaimed rubber, or what we are doing is something similar to reclaimed rubber, because we are doing our best not to use the conventional material of the digester, which when they used to put it on high steam. We are not using additives because some countries, neighbor countries, used to put recycled oil or asphalt, liquid asphalt with the rubber to make it tackier as a reclaimed rubber, and this had a huge repercussion on the quality and the smell. So we take pride that if you want to call it reclaimed rubber, is smell-free. It has the odor of rubber, definitely. It will have the smell of rubber. And it is also additives-free. And this is why we have been able to introduce it in larger percentages in our manufacturing process.
Okay. I think there's a fine line between devulcanization and reclaim.
Yes, there is always a misconception, and there is a big debate about this, because everybody has his method, and everyone has his own maybe hidden patent about it. Not everybody registers the patent because the competition is fierce in that. So everybody has his own way. As long as you be able to reverse engineer the powder into a sheet of raw material that you can use alone or blend, then the options are endless in whatever you can make of products.
Okay, so to bring this to this initial interview to a conclusion, because I'd like to speak to you again later down the line. You're looking for partners, so people who are interested in working with you can contact you at Modern Advanced Polymers, and you'd be open to licensing plants abroad.
Definitely. Yeah. Either helping them with turning the shredded output into useful raw material or products, or maybe teaming up with them into implementing the whole concept from collection to raw material or to products.
Okay. Thank you very much for your time, George. It's been very interesting.
It was a pleasure, and thank you again, and really honored to have had this interview with you.
Well, that lived up to its billing. A great insight into Modern Advanced Polymers. What's your instant reaction to that, Ewan?
It was very interesting speaking to George Kassab. It makes a difference when you're speaking to somebody who has the experience in the industry and who has had the insight to take recycling and polymers and blend them and come up with new products, and has a serious approach to using recycling. And I guess that being in Lebanon, they are under a lot of pressure to do things efficiently and at low cost and find alternative solutions. It's once this COVID pandemic is past, it's one of the places I want to go and see. I want to go and see what Modern Advanced Polymers are doing on site.
Absolutely. Well, I'd quite like to go with you. I've never visited Lebanon, so you could sign me up for that trip as well. But I'm sure it will be great to catch up with George, whether it's in Lebanon or on this podcast in the future to see how they're progressing. But thanks for your time today, Ewan, and I look forward to you joining me again shortly. Until then, thank you for watching.